What is going on, guys, and welcome back to another one of the videos. Well, this is actually recorded right after we did the last video, and the question is, how would you solve this? I mean, this just seems very difficult, doesn't it? Well, let's maybe have a look. So, what is the setting? Well, we have a semicircle, and a semicircle, right? So, at least we can say that all of these circles are 1/2 of the entire circle, right? But that's about it, what we get. So, let's have a look. So the first thing that I can see what we can do is that we can just connect these, right? And we can say that this is 1 and that this is 1.5. And then we can use, can we even use, wait a second. Yeah, so this is where the problem already starts, because we can't even calculate anything here. This is of course also 1.5. So we can actually calculate this, right? But the problem is, well, anyways, let's just maybe figure that out, right? So what is that? So we have this red thing here, right? So let's say red, or let's just say this x, right? X. I can already, I think, skip ahead a little bit. I mean, not a lot, but just a little bit, right? We can say that x is equal to square root of 1 plus 1.5 squared minus 1.5 squared, right? So this is just square root of 2.5 squared, which minus 2.25, right? 2.5 times 2.5, 2.5 times 2.5 is equal to, we have 10, 5, and we have 25, and we have 25, so we have 12, 6.2, okay. So we have 6.25, 6.25 minus 2.25, which is square root of 4, which is 2. Okay, so we just saw something interesting. That this length here is exactly equal to 2, right? There's no approximation. It is exactly equal to 2, because 1 plus 1.5 minus 1.5 squared, right? This is just, again, the theorem of Pythagoras, right? We have the right angle here, is equal to 2.5 squared minus 2.25. 2.5 times 2.5, 6.25. And then we just have a subtraction and a square root. So, what is this telling us? Well, this is telling us that this length is 2. So, oh, wait a second, this is actually telling us multiple things, I think. So, with this being 2, right, it also means that this length right here only is equal to 1, right? So we have from here to here is 1. Why? Because if this whole length is equal to 2 and you have the diameter is 2, then you have 2 minus 1, which is just equal to 1, right? Now the question is, how does that even help us? Well, that's a great question right there. How would we even figure this out? I actually do not know. So guys, I now had a look at the setting, and I think that I figured it out. Now, how do you do this? Well, first I need my pen, which is over there. So there is something called an inscribed angle theorem, I think it's called. And what it states, if I'm right, is that if you connect any 3 points in a circle, you get a right-sided triangle. That's what that says. Jesus, camera tripping. Alright, the camera started to trip a little bit there, but anyways. So, I think this is what this says, that we have an inscribed angle theorem, and if I'm correct, then we can actually calculate this out using this theorem, right? So, we have this side right here, which we know is equal to 1.5, and we have this side right here, which we don't know the length of, and then we also have this side that we're searching for, right? So I don't know if I thought that was going to help us. Guys, I got it. Calm down. So, one important thing to know is that we have the angle alpha here and the angle alpha here. Why? Because it's a kind of z angle, right? So, this thing has the same incline, decline, or incline in this instance, right? All throughout, because it's just a straight line, right? So, what I actually missed was that we actually already know this side, right? And then with Pythagoras, we can just calculate the angles, calculate this, and then in the further, well, later on, just calculate this. So let's do it, right? So we have this whole side, right? This side from here to here, right? From here to here. So I'm just gonna mark this green, right? Green is equal to 1.5, which is half of 3, plus 1, plus 1, plus 1. Alright, so not that difficult, right? 1 plus 1 plus 1 is 3. We have 4.5 centimeters, of course, right? Let's just put some units there also. So we have green is equal to 4.5, so let's just write that there, right? 4.5. Great. Now, what we need to do, use the theorem of Pythagoras again. We have 1.5, 4.5. We can calculate the longest side. Right? So we just say square root 4.5 squared plus 1.5 squared, which is the same as plus 2.25. 4.5 squared is, I have to calculate that here again, 4.5 times 4.5, which is, this is just 20, this is 16, 18, and we have 5 times 5 is 25, we have 5 times 4 is 20, plus 2 is 22, 20.25, 20.25, right? So we have 20.25 plus 2.25, which is just the same as square root of 22.5, which is the same as. So we got 4.7, excuse me, centimeters, right? And from now on, it's fairly simple. What do? We need to use sine, cosine, tangent, right? So we have this side. And we need this angle here. So how do we calculate that angle? Well, we know this side, we know this side, we know this side. So now it's just a matter of applying. So let's say actually, when you have sides given, it's the best to use those two sides. So we have this side. So we use, of course, the sine, right? Sine of an angle is the opposite side divided by the hypotenuse, right? Now we just say arcus sine of opposite side over hypotenuse is the angle. So we just said arcsine of opposite side over hypotenuse is the angle, and this is just the same as the arcsine of opposite side is 1.5 divided by the hypotenuse is our answer. So, that was actually, we should have actually used the tangent, which is what I just realized. So let's actually make that tan arctan closest side arcsine of opposite side, which is 1.5 over 4.5, which is 0.3 repeating. There has been a little bit of a break because there's not enough storage on this camera at the moment, and I don't have a hub, so it's kind of complicated. It doesn't matter though. The thing that we were talking about, right? So, 18 degrees, right? So this is the angle here and here, right? So what can we do with that? Well, it's actually already solved. So what do we need to do? Let's just say that this whole length, right? This whole thing now becomes y, or becomes our variable z, right? So now it's actually a matter of only calculating z, which is fairly simple, right? So what we need to do now is actually take into consideration this length and z, right? So how do we do that? Well, fairly simple, right? We say this length, right, which is just this, is, well, actually, okay, one more thing that we have to think about, which sine, cosine, tangent, what do we use, right? So we can use, this is the hypotenuse, right? And we know the closest side, so we need to use cosine. So cosine of alpha over angle is equal to closest side, which is our, let's just say, which is green. It's not green, no, it's not green, sorry. Which is closest side to hypotenuse, right? So, and now what do we need? We need to calculate out the hypotenuse, right? So we just say h is equal to closest side over cosine of alpha. Good. We plug this into the calculator and we get, and guys, we actually really get a number that is extremely close to just being 5. So, what do we learn from this? Well, I mean, there's nothing really to learn about this. I mean, it's kind of strange that you can pick 2 of these semicircles and then for this to be 5, right? I mean, maybe somebody can explain this in a way in which it makes more sense, maybe. Now, one thing that I thought about is you can actually maybe pull this thing down, you know, let's just like rotate this thing around this axis, and maybe it actually does line up, because that's actually what has to be the case, right? Otherwise this would be not solved. Anyways, so we say z is equals to 5. Alright, thank you guys for watching. As I said, I have to be fairly quick now, but thank you guys for watching. I'll just check if this is correct, then do a quick summary, and that's it. Yeah guys, so I actually looked it up, and 5 is correct. God bless us. This is a little bit more of a difficult way maybe to do it. He did it in a way in which he basically thought about the direct translation and rotation already, but you know, we just did it in the way that the math lines up and is correct, right? So what did we do? Basically, we just said, okay, inscribed angle theorem. We said an angle in the circle has to be 180 degrees, right? The sum of all angles, but it also has to be a right angle triangle. So right angle here, we have alpha there, alpha there. We know how long this is. We know how long this is, right? We calculated this out before, only this length. Then we said, okay, we know also the height, calculated this length, and then we calculated the angle, and then we just did some simple math. It was 5. Maybe another way to think about this is, as I said, take this thing, take this semicircle, move it down, and so you have 2 plus 3, and the semicircle would sit right here. Alright guys, thank you guys for watching, and have a good one. See you in the next one.